Hi, it's me again. So in the previous video we went ahead and explained what we aim to achieve with this project and all the events that led up to this. If you haven't seen that video, I recommend you pause this video and give it a quick watch as it provides some pretty substantial context for what we're going to go over in this video. I'll put the link somewhere down below or in an annotation somewhere on the screen. So in this video we aim to provide you a more in-depth overview on how the project is going to look like and how we're going to structure it. We'll go over several topics such as project architecture, our approach, the technology we'll be using, and the next steps we'll be taking. So I invite you over to the drawing board to go over these topics. So we're here over at the drawing board. I usually find it easier to go over these topics if I'm able to draw them out, and I hope it will be easier for you to understand if you have some visual feedback to go with it. So in the last video we mentioned several different examples of GPS systems that utilize different approaches. Some go for the approach where they just create a standalone unit, which is a device with navigation embedded in itself, while others go for a more symbiotic approach where you have a device and a smartphone app on the side that interacts with each other. For our project, we'll be going for the more symbiotic approach, having a separate hardware unit and smartphone app that will communicate with each other. We have several different reasons for adopting this approach, namely because it allows both entities to focus on one thing and one thing entirely, and to do that thing entirely well. With a device focused on ingesting data from both the application and different sensors. This would allow the device to show you all the information you need so you can just focus on the road straight ahead of you. Meanwhile, the application will be focusing on doing all the big brain thinking work, such as processing and calculating the route, to ensure the device will receive all the necessary data. Additionally, this setup comes with the benefits that the device does not need a powerful processor, as your smartphone is already doing that, which means we have the added benefit that it saves on costs, making the device both more affordable. Additionally, it will also have the benefit that it consumes less electricity, which allows the battery to last longer. I do understand the concerns in regards to having installed an additional app. Plenty of people, including myself, dislike having to install an app when purchasing a device, as they don't really know what it's doing in the background and often provides no real added value aside from, well, data harvesting. But by making our app free and open source, we aim to mitigate this by providing a transparent application where you're free to change whatever you don't like, because the end goal is to have a navigation solution where you simply set the route, put your phone away wherever you'd like your backpack, and enjoy your trip wherever your destination may lead you. So I want to go quickly over the topic of names, as at the start of the project we didn't really have a name for the product we aim to develop. So the idea is for the device to serve as your companion on the road, assisting you to reach your navigation, with the application serving as a computational engine in the background, driving forward the navigation process. With this we came to the idea of this being your navigation companion and this being the navigation engine, or the nav-C and nav-E for short. Of course, we also need a name for the collection of these devices to run with. So with these elements being either something you take with you or being software related to navigation, let us the name Navware with the logo made by our very talented friend over at Powp Studio. Shout out to him, by the way, you can check out his work in the description below. As for the names, from here on out we'll continue referencing the device as the navigation companion or nav-C for short, and the app as the navigation engine or nav-E for short. So that brings us over to the technology side of things. For the navigation companion, we'll be eventually making use of custom hardware running a low power system on a chip, like the system on chips Norton Semiconductor produces, running a real-time operating system. In terms of connectivity, we'll be using Bluetooth Low Energy, as we're aiming to have a battery that lasts at least 8 hours. However, do mind we'll be creating a prototype first, which we'll elaborate later in the video, which we'll likely use a development board in the meantime. As for the navigation companion, we'll be creating the application using the Flutter framework. Flutter is a framework developed by Google that allows the development of applications for multiple platforms using the same base code. We want to make the navigation companion and the navigation engine as widely available as possible, which is why we decided this would be the best approach for our application. Speaking of which, funny story how we discovered Flutter. So back when me and Alaf we were studying software development, we had a class on Android development where we learned some of the fundamentals of developing Android using Android Java. However, the quality of the classes were doable at best, with a lot of material being either deprecated or simply just not explained. And the exam we had to do at the end of the semester was an assignment we had to make in class, where we only got 2 hours to implement several features and style the application properly. Yes, we also got rated on the design of the UI for some reason. I don't know why either. However, Alavi discovered at this time this newly created framework called Flutter and asked the teacher if he could practice that over the semester and make the exam using that. What the teacher didn't know that I do now, having developed several apps using both Android Java and Flutter, is that Flutter makes a lot of things a lot quicker to set up and implement, especially in regards to UI logic interaction. So we're making this exam and everybody's on time crunch because all these features have to be implemented and the syntax has to comply with these arbitrary rules. And at the end, only a few people actually make it on time and pass the class. And here comes Alavi with his Flutter app that didn't need to comply with these weird syntax rules written in like a quarter of the time we got. He was done in 30 minutes, got to go home, and here's the kicker, he got the highest grade out of everybody in class. Like, well deserved to him. I would have done the same if I knew what he knew at the time. But back to the technology. So, as stated before, we'll be using Flutter for our app as we want to make it as widely available as possible without having to maintain several different applications on different platforms. We'll also be looking at false app stores such as F-Droid and Crescent, aside from having our APK directly available from our Git for the Android users. But for now, this is the technological aspect of the project overview. We'll provide more details as the project continues on and new developments and decisions are made. So in terms of our next steps, we have the following in mind. I'll start and admit that we have already been working on the project in the background over the last few months. I know, but we aim to have our MVP/prototype finished at the start of the new year. But do keep in mind that me and Alavi both work full time, so we can only do so much with the time we have. So in terms of the prototype, the navigation engine at this point will be a pretty bare bones application that allows you to connect to the navigation companion and start the navigation either on your phone or the navigation companion. The prototype will be tested on Android first, as those are the only phones me and Alavi have available at the moment, but don't worry Apple users, you'll follow right behind. In regards to Navigation Companion, it will be developed using a development board with pretty rudimentary code aimed at receiving data from the app and orienting itself in accordance to the position it's looking towards. One thing I forgot to mention is that our setup having the Navigation Companion and the Navigation Engine allows us for the possibility of further modular expandability in the future. Think for example of having a gasoline gauge for the motorcycles that don't have them that connects to the Navigation Companion and shows the remaining gasoline in the tank. As usual, the options are limitless, but I do want to hear what kind of ideas you guys might have and might like to see in the far future. Let me know in the comments below. Also let me know down in the comments below if you like this kind of style video using your drawing tablet. And as usual, if you like the video, leave a like, subscribe to keep yourself updated on developments of this project, check out our socials, and have a great day or night, wherever in the world you might be. Thank you for watching.